Question 3. Evaluate each of the following without the use of a calculator. So part 1, root 12, root 3. So these are stuck together, which means they're multiplied. Now it's important to remember when we're working through these questions that root x means root x multiplied by root x, which will give us x. So for example, root 2 will give us 2, root 3 will give us 3, root 7 will give us 7, and so on. Okay, so root 12, we are going to rewrite that using some of the factors of 12. So some factor pairs of 12 are 1 times 12, 2 times 6, 3 times 4. And we want to pick a factor pair that contains a square number if possible. So root 3 we cannot factorize because it's a prime number. So it only has 2 factors itself and 1. So we don't need to factorize root 3. But root 12 we can factorize. So root 12 I'm going to rewrite as root 4 root 3 because 4 times 3 gives us 12. And I've chosen this factor pair because 4 is a square number. And we want to use square numbers if we can because they can simplify even further. So I could have rewritten root 12 as root 6 root 2. But 6 and 2, neither of those are square numbers. So that's why I'm going with 4 and 3. And then root 3 just stays the same because that's already simplified. So we have root 4, root 3, root 3. So the 3 of these now are stuck together, which means we multiply the 3 of them. So it's important, as I said, to remember that root x gives us x. So the square root of 4 will give us 2, because 2 squared is 4. And then root 3 will give us 3, because root x gives us x. So the square root of 4 gives us 2. And then root 3 gives us 3, because root x gives us x. And then 2 multiplied by 3 gives us 6. So root 12 root 3 gives us 6. And you can check this in your calculator. And you might be wondering, why do we need to be able to do these out the long way if we're allowed to use our calculators in our exams? But when we move on to a chapter called complex numbers, you need to be able to work with surds without using a calculator. So it is important to be able to do this now and to understand where it comes from. But it's handy to stick this into the calculator just to check if you are correct. Next, we want to simplify root 20, root 5. So root 5, well, 5 is a prime number, so that can't be simplified, that can't be factorized. But 20 has quite a few factor pairs. So 20 times 1 gives us 20, 10 times 2 gives us 20, 4 times 5 gives us 20. And again, we're going to choose a factor pair of 20 that contains a square number if possible. So we're going to rewrite root 20 as root 4 root 5 because 4 is a square number and 4 times 5 gives us 20. And then root 5 just stays the same. So we end up with root 4, root 5, root 5. So the square root of 4 gives us 2 because 2 squared is 4. And then root 5 will give us 5 because remember root x gives us x. So root 5 gives us 5. But remember that we're going to be multiplying them because these were stuck together, which means multiply. And these were stuck together, which means multiply. So ultimately we have to multiply. So 2 times 5 gives us 10. Next we have root 2, root 8. So root 2 is a prime number, so we can't factorize that, but root 8 we can. So the factors of 8 are 1 times 8 and 2 times 4. So we're going to go with 2 times 4, or 4 times 2, which is the same thing, because 4 is a square number. So root 2, we just write down again, can't be factorized. And then root 8, we rewrite as root 2, root 4. So you could have wrote root 4, root 2, means the same thing. So we have root 2, root 4. So the first root 2 we just wrote down because we can't simplify that anymore. And root 8 we rewrote as root 2 root 4 because 2 by 4 gives us 8. So now we need to remember again that root 2 gives us 2 because root x gives us x. So root 2 gives us 2. And then the square root of 4 is also 2. And these are all stuck together, so we must multiply. And 2 times 2 gives us 4. Next we have root 2 root 32. So again, root 2 can't be simplified because 2 is a prime number. It only has 2 factors, itself and 1. But root 32 can be factorised. So there's a few different factor pairs for 32. But again, we're interested in one that has a square number in it. So we start off by just writing down root 2 because that cannot be simplified. And then the square root of 32 we're going to rewrite as a factor pair that has a square number in it. So we're going to go with 2 and 16 because 2 times 16 gives us 32. And 16 is a square number, which is what we're interested in. Next, root 2 will give us 2 because root x gives us x. And then the square root of 16 is 4. So we're going to have 2 multiplied by 4 because these were all stuck together. And 2 times 4 is 8. Next we have root 50 root 2. So again, this root 2 we can't simplify, but root 50 we can rewrite as factor pairs. And again, we want to choose factors that are square numbers. So we're going to go with 25 and 2 because 25 times 2 is 50 and 25 is a square number. So we're going to rewrite root 50 as root 25 root 2, and then root 2 will just stay as it is. And then the square root of 25 is 5. And root 2 will give us 2 because root x gives us x. And remember, these were all stuck together, so we're multiplying. And 5 by 2 is 10. Next we have root 27 divided by root 3. So root 3 is a prime number, so that can't be simplified. But root 27, we can factorise that. And again, we want to try and choose factors that are square numbers. So 9 times 3 gives us 27, so we can rewrite the square root of 27 as root 9 root 3. And then our denominator root 3 just stays the same, cannot be factorised because it's a prime number. Then the square root of 9 gives us 3, and we still have root 3 over root 3, and they will cancel each other out. So technically we're left with 3 over 1, which gives us 3. Question 7. Root 50 over root 2. So root 2 cannot be factorised or simplified, but 50 has quite a few factor pairs. So again, we want to choose a factor pair that has a square number. So we go with 25 times 2, because 25 times 2 is 50. 25 is a square number. So root 50 we rewrite as root 25 root 2, and then our denominator root 2 just stays the same. So the square root of 25 is 5, and then we still have root 2 over root 2, which will cancel. So we're left with 5. Next we have root 28 over root 7. So root 28 we will factorise to be root 4 root 7 because 4 times 7 is 28 and 4 is a square number. And root 7 is a prime number, so cannot be factorised. Then the square root of 4 is 2. The root 7s will cancel, leaving us with 2. Next we have root 72 over root 8. 72 we factorise to be 9 times 8. So 9 times 8 is 72 and 9 is a square number. The square root of 9 is 3. And then the root 8s will cancel, leaving us with 3. Then we have root 200 over root 8. The square root of 200 we will factorise as 100 times 2. So root 200 becomes root 100 root 2. 100 is a square number. We're also going to factorise the root 8. We didn't bother doing it up in this question because when we factorised root 72, we had a root 8 and we were able to cancel those root 8s. But if we only factorise the top here, root 200, to give us root 100 root 2, then we can't cancel the root 2 with the root 8. So we're going to have to factorise root 8 as well. So root 8 we factorise as root 4 root 2. So we have a square number, which is 4. Then root 100 will give us 10. The square root of 100 is 10. And the square root of 4 is 2. And these root 2's will cancel. So the square root of 100 is 10. And the square root of 4 is 2. And now the root 2's will cancel. And 10 divided by 2 is 5.